Okay, so we're going over solving polynomial equations. They've given us a word problem. They said we have a piece of cardboard and we need to create a box. So the cardboard's length is 70 centimeters by 50 centimeters, and they're hoping to create a volume of 4,000 centimeters cubed in total, right? Hopefully this works since we just made the numbers up ourselves. I think we should get something. They want the box to be an open top box, okay? So what they mean by that, and we'll try to put this together, an open top box will be something like this, okay? Let's see if we can, yeah, that wasn't bad. Okay, and in other words, what this means is this part, there's nothing there, okay? So what's going to happen to make an open top box is this is actually going to end up being the bottom of the box, okay? This part here is going to fold up. This part here is going to fold up to make a wall. This will fold up to make a wall. And this will fold up to make a wall. Does that make sense? Yeah. So this part is excess. We can't do anything with these four corners here. We have to cut them out in order to make the box not have pieces hanging out the sides, right? So we don't know how large to cut these pieces, so we're going to call them distance of x, essentially. So from here to here will be the distance of x, and what we're going to do is we're going to make them square type cuts, okay? So what that also means is from here to here will also be x. We're going to cut squares out instead of rectangles, okay? Just to make this simpler for us. Once we cut different sizes, that would have to be different variables. It makes the question a little more complex, okay? So we'll label each of these lengths and widths x and x and x and x. Okay, now here's the thing. First of all, we need to figure out, once we cut those, how long each of the sides are going to be. How long will this side of the box be once we cut out these squares, these pieces of rectangle? Essentially, how long will this to this be? Do you know? Can I make an equation to represent that? From here to here?
70 minus 2x.
That's right. Because we're cutting out two of the x's, the inside of this will be 70 minus 2x. In other words, we'll call that this side, 70 minus 2x. That's what this part of the box is, okay? What about the other side of the box?
50 minus 2x.
That's right. This here would be 50 minus 2x, okay? 50 minus 2x. Now, finally, when we fold this box upwards, okay, because we're talking about volume, we know volume is, because it's a rectangular shape, length, width, and depth, whatever you want to call each, right? We have our volume over here going to be 4,000. So we know that our length times our width times our depth is going to equal 4,000, okay? What is the height of this box going to be when we fold these up? In other words, this will be the height once it's folded, right? How long is this side here? X, that's right. So the height of this is x. Okay, so we now have a length, a width, and a depth. We'll call it d for the x there. So let's put this equation together. There we go. So our length, we said, was 70 minus 2x. multiplied by the width being 50 minus 2x, and the depth being x itself is equal to 4,000. Okay, well, we're going to distribute all of these to figure out what they are. Because it's multiplication, I can technically do it in any order. So this will be 70 minus 2x, and this will end up being 50x minus 2x squared is equal to 4,000. Okay, we'll distribute again. 70 times 50 is going to give me 3,500x. 70 times negative 2x will give me negative 14x squared. 2x times 50x gives us negative 100x squared.
70 times negative 2.
Oh, 140. Sorry, I did 7 times negative 2. Good. Good eye. What did we just do there? Negative 2 times 50x. Yep, that's right. And negative 2x times negative 2x squared is positive 4x cubed, right? is equal to 4,000. Okay. What we're going to do is collect our like terms and set this equal to 0 so that we can try to factor, or even might have to divide in order to find out what our possible values of x will be. So when we collect our like terms, and we'll put this polynomial kind of in order, this becomes 4x cubed. This will become minus 240x squared and plus 3,500x. Right? And then I'll bring the 4,000 over, so subtract 4,000 is equal to 0. Okay, so now what we have is a rather long polynomial. Calculus, you'll learn a fast way to do this, but we haven't got to that yet. So we need to find essentially factors of this. Hopefully there is a factor of this because we did make this question up. We're going to hope that there's a whole number factor to this. So we need to try values, and remember one of the ways was to find factors of the first two terms when they're multiplied together, the first and last term. So that would give us 16,000. We should try some factors of that to see if we get a 0 in our x here. Okay, so that's going to be our first part. We're going to take a second to do that, just because it could take a little. So since we made that question up, it became a little difficult. Really, we might not actually find a factor in that one. We just pulled numbers arbitrarily. So I went back and changed this. I'm going to change the volume of this just to a number that I know is going to work. So let's say we're actually trying to find a volume of 15,000 centimeters cubed. Okay, it's not going to change much. Or just all the numbers that said 4,000 before. We're just going to quickly switch them over to 15,000. Okay, so in the question here, these 4,000s are going to become 15, and when we bring 4,000 to the other side, instead of becoming negative 4,000, it's just going to become negative 15,000. Just because we know, well, I've gone back and checked that this will be a value that's going to work for us. Okay, in fact, 4,000 might have been a value that was unacceptable. It didn't work. It was just going to take us a long time to figure that out. Okay, so let's say we got this. 4 is a common factor here. So let's take 4 out as a common factor. We're left with x cubed minus 60x squared plus 875x, and 4, I think, comes out of 15,000. Divide 4, does it? Yep, 3,750. 3,750. Now, I'm pretty sure that 10 is going to be a value that might work for us. Minus 60 times 100 plus 875. Yeah. 10 is going to be a value that works. Okay? 10 will be a value that works for us here. So, in other words, what we're going to be taking out is we know 10 is a factor of this. Okay, so let's go and use our synthetic division. Okay, if we were to use long division for this, we'd be using x subtract 10. Okay, but we're going to use our synthetic division, so we're going to be using just our number 10, and we're going to bring our values down. So the coefficients of each of our terms. Well, the coefficient of our first term here is just 1, right? Coefficient of the second term is negative 60. Third term is 875, and the third term is negative 3,750. Okay, so we bring the 1 down, we're left with 10. Whoa, that's a lot. We're left with 1. 1 times our number gives us 10. So 10 here, and we're going to add. What's 60 plus, or negative 60 plus 10?
Negative 50.
Negative 50. Okay, we're going to multiply that by 10. We're going to get negative 500. Let's add those two together. Take a quick calculator out here. Do you know what it is? Think of it like straight subtraction. 5, 7, and 3. Okay? If you take a calculator, you would have found the same thing. Then we're going to multiply that by 10. And when we multiply that by 10, we get 3,750. Perfect, right? We get a remainder of 0. So we've taken a factor out. Let's write what this polynomial kind of looks like now. We've taken our factor out of x minus 10. And the rest of the polynomial reads x squared minus 50x plus 375. Okay, now we've written the polynomial like this. This is one of the factors, but there's other options too. Okay, we might need to factor that. The best way to factor that, instead of going through our factoring, would be quadratic formula. We know it's going to work right away. So we'll use the quadratic formula right off the bat to factor this. So we know x is equal to negative b plus or minus the square root of b squared. You remember this whole formula?
Yeah.
Okay, good. B squared minus 4ac times 2a. Okay, so negative b will give us actually positive 50 plus or minus the root of, what would negative 50 squared be? How many zeros?
2.
Yeah, that's right. Okay. Minus 4 times a is 1 and 3 is 375. So we'll go figure that one out with a calculator quickly. And 2 times a, what was our a value again? 1? So it's just going to be 2. That's simple. All right, let's do this underneath our square root very quickly. 4 by 1 by 375 is 1,500. And we know we have 2,500, subtract 1,500, right? So minus 2,500. We're just going to get the positive value of that, so 1,000. So we have 50 plus or minus square root of 1,000 divided by 2. Okay, well this is where we kind of can branch off into two numbers. Let's take the positive value of that and root it. 31.62. Okay? So, in other words, we're going to get two answers here. We're going to have 50 plus 31 point, what did we say? 62. That was the square root of 1,000. Divide 2. And we're going to get 50 minus 31.62 divided by 2. Okay? These will become, quickly bring this up, that plus 50 divide 2, 40.81. And in our other one, 50 minus 31.62 equals divide 2. 9.19. 9.19. Okay, so what we've actually found is three factors. Let's not forget this. 40.81, 9.19, and the very first factor we found, which was 100. Okay, so what I'm going to do is I'm going to redraw this question down at the bottom. Not 100, sorry, 10. I'm just going to write that on the side. So this is our other factor, 10. So now that we have all those, I'll quickly redraw our box here. Remember our box was, what did we say, 70 by 50, right? Yeah. So it was 70 by 50, and we were going to cut little pieces off. We need to make sense of what the pieces are going to be. So we knew the new measurements of the box when it's standing up is going to be 70 minus 2x, 50 minus 2x, and the height of x. Okay, well, let's quickly think about this. If x is 40.81, what is 2 times 40.81, roughly, for an estimate? 80, right? So what is 70 minus 80? Negative 10. Can I have a distance of negative 10? Or no? So this one doesn't logically make sense. The 9 will work, 9.19. We can actually figure out what those measurements are going to be, and we'll go ahead and test them too. So, and the 10 will work too. So what I'm going to do is we're going to do two steps. We're going to do one of them where our x is equal to 9.19, and the other one when x is equal to 10. Let's see how we get this. They should both technically work, it looks like. There we go. So, if this is the case, our volume is equal to the length being 70 minus 2 times 9.19 times 50 minus 2 times 9.19, and then all times 9.19. Okay? Does this make sense?
Yeah.
These are the three measurements, right? Here's one of them, here's the other, and this was the height. So we'll quickly try to work this out on a calculator. 2 times 9.19, 18.38. So 70 minus 18.38. 50 minus 18.38. And then, of course, we have our 9.19. Where's that calculator? There we go. So 70 minus 18.38. 5162. $50 minus 18.38, 31.62, and then finally 9.19. So what we've discovered for our box is our length will be 50.61, our width will be 31, and our height we'll say is 19. Now let's check to make sure, because remember we changed the volume to 15,000, right? Let's make sure these values end up working. There was a bit of rounding involved, so we might be a centimeter or two off, but let's check it out. 51.62 times 31.62 times 9.19. Yeah, it's pretty much 15,000. Okay? So these measurements worked. That's one option. Our other option is 10, right? Because we deduced that 40 was no good. Now, 10 is going to be a little easier. I can do a lot of that with my mental math, I think. Hopefully. Am I at the bottom of this page? I guess so. Okay, I'm going to have to break it here. The page doesn't go any farther. Our volume is going to be, now I'm going to do this in my head, 70 minus 2x. Well, 2x will be 20. 70 minus 20 is 50. Is that okay? As the length. The other one was 50 minus 2x. 2x is 20 again. That's going to be 30. And then that was our width. And then our height was 10. 50 times 30 is going to be 1,500 times 10. It's going to be 15,000 on the dot. So technically neither of these are wrong. Okay? I could cut 19.19 my x height, or I could do it of x to the 10. The question really becomes, what do I want the perimeter or the surface area of the box to be? And that's it. But we found two answers. The 40 was no good because it made it too large. But quite a bit of work to that.
Yeah.
Especially with the factoring involved, okay? We found everything in the end, though.